Hi people, welcome to the ninth part of our statistics series. In this video, we are going to discuss about kurtosis. Please watch my previous videos on normal distribution and skewness to understand this video. Kurtosis is the measure of tailness of a distribution. Kurtosis is the sharpness of the peak of a frequency distribution curve. It describes the shape of the distribution of tails in relationship to its shape. Tails are the tapering ends on other side of the distribution. They represent the probability or frequency of values that are extremely high or low compared to the mean. In other words, tails represent how often outliers occur. Outliers are data points that are far from other points. In other words, they are unusual values in the dataset. Outliers are problematic for many statistical analysis because they can cause tests to either miss significant findings or distort real result. In this diagram, that single dot is an outlier. We will study about outlier in further videos. For now, we will understand that an unusual value of a data set is an outlier. Kurtosis can help us know if there is an outlier in the data. So now we will discuss on the types of kurtosis. So a mesokurtic distribution is a medium-tailed. So outliers are neither highly frequent nor highly infrequent. Kurtosis is measured in comparison to normal distributors. Normal distributions have kurtosis of 3. So any distribution with a kurtosis of approximately 3 is mesokurtic. For example, a female elephant weighs an impressive 210 pounds at birth. Suppose that a zoologist is interested in distribution of elephant birth weights, so she contacts zoos and sanctuaries around the world and asks them to share their data. She collects birth weights data for 400 female baby elephants. From the graph, we can see that the frequency distribution shown by gray bars approximately follows the normal distribution shown by green curve. Normal distribution are mesokurtic. The zoologist calculates the kurtosis of a sample. She finds that kurtosis is 3.09. The excess kurtosis is 0.09, and she concludes the distribution is mesokurtic. Although a population's probability distribution can have kurtosis of exactly 3, real data is almost always at least slightly platykurtic or leptokurtic. If a sample has a kurtosis of approximately 3, you can assume it's drawn from a mesokurtic population. Mesokurtic distribution have outliers that are neither highly frequent nor highly infrequent, and this is true of the elephant birth weights because occasionally a female baby elephant will be born weighing less than 180 pounds or more than 240 pounds. Now about platykurtic distribution. A platykurtic distribution is thin-tailed, meaning that outliers are infrequent. Platykurtic distribution have less kurtosis than normal distribution. In other words, platykurtic distribution have a kurtosis of less than 3 and an excess kurtosis of less than 0. Platykurtosis is sometimes called negative kurtosis since the excess kurtosis is negative. Platykurtic distribution can be given by an example where a sociologist is studying the social media use of students at a small high school where there are 400 students at school ranging in age from 14 to 18 years old. The frequency distribution table is shown above by the gray bars. Doesn't follow a normal distribution shown by the dotted green curve. Instead, it approximately follows a uniform distribution shown by the purple curve. Uniform distributions are platykurtic. The sociologist calculate the kurtosis of sample is 1.78 and its excess kurtosis is minus 1.22. He concludes that the distribution is platykurtic. Platykurtic have low frequency of outliers. Uniform distributions like distribution of students age are extreme cases of platykurtic distribution because outliers are so rare that they are completely absent. There are no students younger than 14 or older than 18 years old. In the graph above, notice that on far left and the right sides of the distribution, the tails, the space below the uniform distribution curve, purple is thinner than the space below the normal distribution curve green. This is what is meant by thin tails. So let's study about leptokurtic distribution. A leptokurtic distribution is fat-tailed, meaning that there are a lot of outliers. Leptokurtic distribution are more kurtotonic than normal distribution. They have a kurtosis of more than 3 and excess kurtosis of more than 0. Leptokurtosis is sometimes called positive kurtosis since excess kurtosis is positive. For example, imagine that 4 astronomers are all trying to measure the distance between Earth and Nu-2 Draconis, a blue star that's a part of Draco constellation. Each of 4 astronomers measures the distance 100 times and they put their data together in the same data set. The frequency distribution shown by the gray bars doesn't follow a normal distribution shown by a dotted green curve. Instead, it approximately follows a Laplacian distribution shown by the blue curve. So Laplace distribution or leptokurtic. In our example, the astronomers calculate the kurtosis of the sample is 6.54 and its excess kurtosis is 3.54. They conclude that the distribution is leptokurtic. Leptokurtic distribution have frequent outliers. The distribution of the astronomers' measurements has more outliers than you would expect if the distribution were normal, with several extreme observations that there are less than 50 or more than 150 light years. If you look closely at the graph above, you will notice that on far left and the right sides of the distribution, the tails, the space below the Laplace distribution curve blue is slightly thicker than the space below the normal distribution curve green. This is what is meant by fat tails. Kurtosis of a population is given by mu negotiation 4, which is equal to mu 4 by sigma 4. Mu negotiation 4 is the standardized fourth moment. Mu 4 is the unstandardized central fourth moment, and sigma is the standard deviation. Hoping my videos are a lot of help to you. If you feel this content to be interesting, share the content, then like, comment and subscribe for more.